So in this question we have two triangles stuck together, so we're probably going to end up using one triangle to help us work out something in the other triangle. Let's take a look at what they're asking. The diagram shows a quadrilateral ABCD, the length of AC is x, and I want to use the cosine rule in this top triangle to show that 2x squared minus 17x minus 168 equals 0. Now, don't worry too much about this quadratic formula sitting down here at the bottom of the page. It's told me to apply the cosine rule to this top triangle. And I can see that I do have three sides and one angle, so that makes sense. Remember to use the opposite in the triangle means opposite in the formula rule. Do not write x squared equals, because x squared, x is not opposite this angle. 12.5 is opposite the 60 degrees, so if I substitute into the cosine rule correctly, I'm going to have to go 12.5 squared equals x squared plus 8.5 squared minus 2 times x times 8.5 cos 60. It is a hugely common mistake to start every cosine rule question with the thing you want, x squared. This is why it's so important to pay attention to this opposites rule when you're using the cosine rule. Now I want to do some number crunching, tidying up and sort this thing out, right? So 12.5 squared can be worked out, and that's coming out as 156.25. 156.25, that's equal to x squared plus 8.5 squared, which is 72.25. 2 times 8.5 times cos 60 I'll do on the calculator. So 2 times 8.5 times cos 60 is coming out to be 8.5. 8.5x. So we can now see this thing is quadratic, and I'm going to tidy the thing up and get it equal to 0, because that's what we always do with our quadratics. X squared minus 8.5x, and then I have to bring the 156.25 over the equals and combine it with the 72.25. So I'm doing 72.25 minus 156.25, and that's getting me minus 84, and that's equal to 0. This thing looks a little bit like theirs, but not quite. Now they've got a 2x squared and I've got a 1x squared, so if I take the whole equation and scale it up by multiplying by 2, I will get 2x squared. 8.5 times 2 is 17x, and 84 times 2 is 168. So we've now managed to reach the stage that they've got to over there. See, it's not important to look at their quadratic until we're quite near it. We need to start at the beginning with the formula. Now it asks us to solve the equation. So I'm just going to stick the A is 2 and B is minus 17 and C is minus 168 into my quadratic formula, and I'm going to work myself out an answer. I've already shown this in previous worksheets, so I'm not going to repeat all that work now. Instead, I'm just going to write down our answers. So we've got x equals 14.35. We've also got x equals minus 5.85. Now both of these are solutions to the quadratic equation. However, only one of them makes sense in this triangle, and hopefully we can appreciate that that's going to be the positive answer. So that's the one I would use in any future work in this question, but there's my answers to my quadratic. Now in the next part of the question, it wants me to work out the length of CD. I'm going to call this length y because we've already used an x. And this is why I refer to these questions as stepping stone questions, because the work I did beforehand is now going to help me. These two triangles share a side, and so I can use that shared side to help me work out y. Now it told me to use the sine rule, which makes sense. So I'm going to go straight ahead and go y over sine of its opposite angle is equal to 14.35 over sine of its opposite angle. If I multiply up by sine 46, I can get myself a solution. That's given me 12.2 centimeters for y. Finally, it wants me to calculate the area of the quadrilateral. So the area of the quadrilateral is going to be the area of both triangles added together. Let's call this area A1. I'm looking for my A for area, and over here I see that A for area. I don't have either of these angles, so they're no good. That's a half times 8.5 times that's 14.35 we worked out earlier, times sine 60. I can work that out now. A half times 8.5 times 14.35 times sine 60. And I'm getting 52.8 out of that. A2 down here, I'm looking for another A for area. Well, I actually have a choice. I could draw my A for area over here near C, or I could draw my A for area... Oh no, I can't. I don't have a choice. It has to be here. Those are the only two sides that I know, and there's an angle in between them. So for A2, following that A for area, I've got a half times 14.35 times that value for y that we worked out, 12.2 centimeters, times sine 76. Area 2 then is a half times 14.35 times 12.2 times sine of 76. And that's getting me 84.9. So the total area, of course, is just these two things added together. 52.8 added to 84.9 gets me a grand total of 137.7 centimeters squared. So three significant figures, we'd write 138 centimeters squared. Now we're asked to work with this little triangle over here. A little bit of a holiday after a very difficult question. Calculate the area of the triangle. I need an A for area, where I know all the sides and angles. There's my A for area. And so we've got area equals a half times 7 times 10 times sine 40. And we just go ahead and work that out. That's coming out as 22.5 centimeters squared. Now I want to calculate the perimeter of the triangle and show that it's 23.5 centimeters correct to one decimal place, showing all my working. Perimeter, of course, is the length of all the sides, so I'm going to need to work out the length of this side over here. This becomes a problem then, which involves three sides and one angle. It's a cosine rule question. Looking for where the opposite is, this side and this angle want to appear on opposite ends of my formula. X squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times cos 40. I can now work out x squared by typing all that into the calculator. And that's getting me 41.753 and so on. Remember to take your square root. This is clearly much too big. Getting x equals 6.46. So the perimeter is equal to 6.46 plus 7 plus 10. So if I do that, add the 7, add the 10, I can see that I'm getting 23.46, which rounds to 23.5 centimeters to one decimal place. So just a note before we move on that in this cosine rule question, the thing we were trying to work out, x, did appear at the beginning, but only because it was opposite the angle. In the previous cosine rule question we did, x was not opposite the angle, so it didn't go at the beginning. So here's another stepping stone question, two triangles stuck together. Note straight away that one of these triangles is a right-angled triangle, so I'm going to get to do simpler things like SOHCAHTOA and Pythagoras when I'm working with this triangle. So let's take a look. The diagram shows a field ABCD, and I want to calculate the area of that field, which means I need the area of both of these triangles. Let's look at the right-angled triangle first because it's going to be simpler. I don't have to work with a half AB sine C. I get to do a half base times height, because the 100 is a base and the 70 is a height. We know this because they exist at right angles to each other. So area 1 is going to be a half times 100 times 70. Now a half of 70 is 35, and 35 times 100 is simply 3500 meters squared. The second area, I don't get to do that, but I do get to use my A for area trick. So for the second area, I can see that A for area arrangement over there. I've got a half times 100 times 110 times sine 40. And that's all going to come out as 3535.33 and so on. So the total area, that's going to be equal to these two things added together, and that gives me 7035.3 square meters. Now it wants the perimeter of the field ABCD. Well, in the simpler triangle, I can see that I'm missing one measurement, which is this measurement over here. I can get that using Pythagoras. So, for part B, x squared equals 70 squared plus 100 squared. Remember, the two shorter sides have to combine to balance out the longest side. So adding these together and taking a square root will get me my answer. 70 squared plus 100 squared, square rooted, gets me 122.1 meters. Now the missing side in the other triangle I'm going to label as y. This then becomes a problem involving a non-right angle triangle, 3 sides and 1 angle. It's a cosine rule question. I first of all note which side and angle are opposite, so that I know which ones to substitute into my rule. So I can now say y squared on one end and 40 on the other, because they're opposite in the triangle. Y squared equals 100 squared plus 110 squared minus 2 times 100 times 110 times cos 40. And I can go ahead and work that out, remembering to do my square root as well. And at the end of all of that, I'm going to have my answer. And that's getting me 72.4 meters. So for the perimeter, that is 70 meters along this side, plus 72.4 along this side, plus 110 along this side, plus x, which is 122.1 along this side. The 100 in the middle is not part of the perimeter, because the perimeter is just the outside sides. So 70 plus 72.4 plus 110 plus 122.1, that all combines to give me 374.5 meters. Or 375 meters to 3 significant figures. Now we're also being asked to work out the shortest distance from A to CD. Now remember how we did this before. Shortest distances go at right angles. So, getting from A to CD, I would need to approach at 90 degrees. And I want to know what this is. We'll call it Z because we've run out of X's and Y's. Now I could use this right-angled triangle on its right or the right-angled triangle on its left. The right-angled triangle on the left looks nicer because I have a length in that triangle that I know, and I have an angle as well. So the triangle I'm working with has Z along one side with the right angle, a 40-degree angle down here, and 100 on the hypotenuse. I can use SOHCAHTOA because it's a right-angled triangle, and I'm interested in a formula with the opposite and hypotenuse in it. So I'm going to say sine 40 is equal to the opposite, Z, over the hypotenuse, 100. And by multiplying by 100, I can get the value of Z. 100 times sine 40, that's equal to 64.3 meters. That's part C. Part D says B is due north of A. Find the bearing of C from B. So if I'm standing at B and I want to get to C, the bearing I'm after will be the clockwise turn from that north line until I'm on that line pointing down towards C. Now this part over here is clearly just 180 degrees. So what I need to work out is the size of this angle over here. I'm in a right-angled triangle, and I'm interested in a formula which uses the opposite and the adjacent. So tan theta equals 100 divided by 70 is the one I want to work with. Theta is the inverse tan of 100 over 70, and I can work that out on my calculator. The inverse tan of 100 over 70 is 55.0 degrees. So the bearing I'm after will add together that 55 degrees and the 180 degrees on the outside of the triangle. And that's going to get me 235.0 degrees for that bearing. I'll do the final question, because it's quite a big question, in one last video.